Bonjour tout le monde. Est-ce que vous m'entendez? Hello there. Do you hear me?
Yes, Mrs.
Est-ce qu'on peut commencer maintenant, s'il vous plaît?
Yes, we can.
On commence et je fais accepter les gens au fur et à mesure, ok? So, let's begin with mineral chemistry. Est-ce que vous voyez le lien? Est-ce que le partage est bon?
Oui, on le voit, c'est bon.
Très bien. Donc, vous avez reçu en principe sur votre... je l'ai envoyé cet après-midi, début d'après-midi. Après, si vous l'avez vu. So, it's about mineral
Oui, on a
chemistry. Ah bah très bien, je vous remercie pour votre réponse.
Je vous en prie.
Ce que vous allez voir aujourd'hui, ce n'est pas une information nouvelle. Ce que vous avez vu et fait déjà en première année de votre graduation, c'est la première année de votre université, c'est-à-dire à savoir la chimie atomistique. Je vais seulement parler en anglais, c'est-à-dire pour vous apporter les mots et la prononciation et voilà, les mots que vous avez l'habitude de voir en atomistique, vous allez voir en anglais avec moi aujourd'hui, d'accord? Je vais pas trop tarder. Et d'ailleurs, c'est pas quelque chose de difficile, mais malgré tout, si vous avez besoin d'éclaircissement, n'hésitez pas à m'interrompre et de me poser vos questions, ok?
Ok, madame.
So, thank you. So let's start with mineral chemistry. We are going to see a periodic table of elements and the constitution of the atom. It's about all the knowledge that you have seen the first year of your graduation, I mean last year. So it's not a news or the news for you from mineral chemistry. It's already you have seen and you know about it. So what the aim of our lesson today is to have a knowledge, how to pronounce and how to write some words that you have the habit of to see them in French, and today you are going to see them in English. So it's not new for you. Periodic table of elements, as always, as you know, it's about Mendeleev. It means it's not created by Mendeleev, it's finished or established by Mendeleev in 1885, 84, 85. He was, if you want, he finished his work according to scientists before him, and he put all elements available at that time on such table of elements with such rules that after him, people until now keep the same rules to give their man-made elements, because there is a lot of man-made elements. It means not natural elements. They are made by men, and they are put in the periodic table. So they make the same rules that Mendeleev gave it a century or 2 centuries before. So the elements are arranged vertically, and we call them groups. If you want the table, you have columns and lines. The columns, we call them groups. And when we put them in the line, I mean horizontally, we call them periods. Okay, so the elements are in groups and periods. If you look at the one atom of every element in the group, you would see that each atom has the same number of electrons in its outermost shell. For example, For example, for beryllium and magnesium atoms, that we have two electrons, they have the same number of electrons in their outer shells. So what we have here, each columns of all the groups contain atoms with they have the same number of electrons in the outer shells. The same thing for period. The name of outer or valence electrons in an atom affects the way an atom bonds. The way an atom bonds determines many properties of the elements, and this is why elements within a group usually have similar properties as usual. So the same for periods. If you looked at the atom from each element in a period, you would see that they have the same number of electron shells. For example, potassium, iron, and krypton atoms, that we have the same number of shells, each of each one. So each group has distinct properties. The periodic table is divided into several groups based on the property of different atoms. As a matter of fact, it's not several groups, it's 8 plus 6, 14 groups. It's not much. So the first one, the first group, or in the first column, situated on the left of the table, we call them alkali metals or alkaline. So alkali metals that we have lithium, sodium, potassium, rubidium, cesium, and francium. They belong to alkali metals. They are soft, severely colored, and very reactive. This is the physical properties of the alkali metals. And the group, we show it by Greek one, Roman one, Greek one A. We're going to see this afterwards. And so an example of an alkali metal, like sodium, solid sodium, that we could cut it with a knife. And you have this listing of alkali reactant. I have to accept your friends to your. So we have here the list of alkali metals that we have from the least reactive to the more reactives, like cesium. We are going to see now the group 2A with alkaline earth metals that are of beryllium, magnesium, calcium, strontium, barium, and radium. These alkaline earth metals are just next to the first column. This is the second column that we called group 2A. It is just next to the one other that we have seen now. And this is some physical properties like several white metals. They are fairly reactive. They are not as reactive as the first group, and many are found in rocks in the Earth's crust. We've got here in purple transition metals. Transition metals, if you do remember of these metals, that they have the shell D are not completed by electrons, that we have to name it transition metals. They are most of them are good conductors of electricity, malleable and easily bent, hammered into wires and or sheets. Sorry, do you have any question? I guess I heard some combination. So This is transition metals. Okay, and this is the metalloid metals that lie on either side of the staircase. What we see here in green, they are listed like a stair. You see, here's the line here is like a stair. Between for each yellow here is the transition metals, and what we are showing here in blue, they are non-metal elements. So they share property with both metals and non-metals, and some of them are used as semiconductors. This is about metalloid. This is the non-metal that I was talking about. We have this group of boron, carbon, nitrogen, oxygen, and of course add in with hydrogen. This is all these elements are non-metals. They are brittle, such they're brittle, and don't conduct electricity. Okay. Now we go to the just next to the column next to non-metals. We could find this fluor, chlor, brom, etc. That we called halogens. So halogens, as a matter of fact, fluorine, chlorine, brom, iodine, and adamant are halogens, and most of them are poisonous, and they are fairly reactive, and they react essentially with alkali metals. A lot of these compounds, like chlorine and iodine, are very reactive and very dangerous for the human health, like chlorine, that was used for the First War and Second War as a weapon to distract some population by poisonment, and that leads to the death by suffocation. So it's very, very, we have to manipulate chlorine with great careful, because it's very dangerous too. But it's a good agent to clean water and some aqua solution. This is the atom of chlorine. Now we have to see at the end of the table, the last one, I mean the last column, it's about noble gases, or we could call them rare gases. They are rare in the atmosphere. It's about 1% in the air, and it includes, of course, helium, neon, krypton, radium. They are unreactive because they can't react, and they can't make bonds with other chemical elements. And there is principally their physical properties is gas at room temperature. If you have seen the jellyfish lamp are made with noble gases because they have such colors. You could see here the color corresponding for each noble gas. So we're going to see the last lines of the periodic table, such as lanthanides and actinides. We could also call them rare earth metals. They are soft minerals that can be cut with a knife, hard to separate when found in the same ore. And same thing for actinides. They are radioactive and stable and decay to form other elements. Most are synthetic elements, means made by the men, most of them. So we could say here the non-thallides and the actinides. Here in the periodic table, it's the last two lines of the table. So the older periodic table is shown with two numbers A and B. A for the periodic tables and B of the groups of the periodic tables. So we have the first and the second column with 1A and 2A, and we have here 3A, 4A, etc. until 8A, and the transition metals that we are shown with B. And if you remember, I have seen last year, these transition metals, they called by B because they have before last 10 shells, D is incomplete. Okay? So in the first column that we called 1A are called alkali metals because they react with water to form an alkaline solution. They are a basic solution if you want. They are very reactive. They react especially with halogens. The group 2A, it is next to 1A, are called the alkaline metals because they are reactive, but not as reactive as group 1A. And they are also soft metals. And before last 10, 7A, it's halogens, fluorine, chlorine, etc. These need only one electron to fill their outer shell, and they are very reactive, especially with alkali metals. And the last group is 8A. It's about noble gases, as they have completely filled outer shells. And of course, they're completely non-reactive elements. So mirror here, elements that are usually solids at room temperature, and most elements are metals in the periodic table. The non-metals element in the upper right corner of the periodic table, their chemical and physical properties are different from metals. And we've got metalloid, elements that lie on diagonal line between the metals and non-metals. And of course, their chemical and physical properties are intermediate between the two elements, means metal and non-metal. So let's see now the constitution of the atom. The atom is composed of nucleus in the center of the atom and with shared with electron cloud. It's surrounding the nucleus. The nucleus is composed by protons and neutrons, especially. Okay, so the composition of the atom. So the atom is mostly empty space, and large space between electrons and the nucleus. Protons and neutrons are in nucleus. The number of electrons is equal to the number of protons. And of course, each atom has its proper number of protons, and the electrons too. So electrons in space around the nucleus, they are with circular movement around the nucleus. And of course, the atom is extremely small, very small that we couldn't see with our eyes, and we need to have such a sophisticated intelligence to could see the atom, of course. So this is the atom, and the composition of atom plus atom plus atom plus atom, we could have compound. So compound is composed of two or more elements in fixed ratio of atoms. So the properties, I mean, chemical and the physical, differ from those individual elements. Like for example, the table salt, which is sodium chloride and HCl. So the table salt doesn't have the same uh, physical and chemical properties as chlorine itself alone or sodium alone. Okay, it's different from the compound from the atoms. So a molecule, so we have atom and compound. So a molecule is more than two atoms, but they are linked with bonds. Okay, they are linked with some bonds, so bonded together. So they may be the same elements that we called the atomic molecule, or they may be different elements. Like here, for example, caffeine. We have a lot of examples. There's a billion and billion of examples according to the molecular examples. We're gonna see isotopes. I guess, of course, you do know very well what does it mean isotopes for you. So atoms of the same element means the same Z but different mass number are called isotopes. And of course, you know how to calculate the mass and the evidence of their existence too in the nature. So the isotopes are there and their uses when the X radioactive X, to see the bones scans. This is the use of isotopes. And of course, you do know the carbon 14. Well, usually we have carbon 12. 14 is an isotope of carbon 12, but it's radioactive. It's such an example of an isotope, isotope of carbon. So to show the name of the element, we do have an atomic symbol. It's composed by a nifen and the mass number of nifen rotation. Like here you have sodium 23. Show the mass number and atomic number in nuclear sample form, like we have here, to show how to express with atomic symbols. 11 here is not his place. His place is just under 23. Okay, so Na 23 and 11. 11 is the number of electrons, and 23 is the mass number. So from this example, which is the isotopes of this same element, according to you, which of the following present the isotopes for you? It's a question. You could answer me. Do you hear me there? Where is the isotopes here in the example? People, are you hearing me?
They are all isotopes.
No, there is one is not isotope.
Second
We do
one.
have three. One, yeah. One and
3 and 4.
they have this 3 and 4. Thank you. Good. So we have 1, 3, and 4 because they have the same A, the same, pardon, they have the same Z, I mean 92, and different A. different mass. So the 1, 3, and 4 are isotope because 2 is the similar of 1, but they have the Z different, and it's not. It's another one. It's not an isotope. Okay. Thank you for who answered me. So let's see with the ions. If everybody knows what does it mean, ions. Ions is the atom. They are atoms of the groups that you have to see with a positive or negative charge. It means donating an electron from an atom gives a cation with a positive charge, and accepting an electron to an atom gives an anion with a negative charge. So to make difference between atom and ion, just to look up, it means the superscripts of the atom. If you have a plus or minus, +2, +1, or -2, -1, -3, so this is our ions. And the atom without any superscripts, they are the atom, simply atoms. Okay? So the ion is charged atoms, atom with charge, positive or negative. So forming cation and anions. So a cation forms when an atom loses one or more electrons, like here magnesium. They lose 2 electrons to give us a cation, which is Mg+2. And the anion forms when an atom gains 1 or more electrons. Okay, so here fluorine is accepting 1 electron to become F-. So this is the anion and this is the cation. As to go in summary here, so predicting ion charges, so we have cation because they are charging positive, and anion is charging negatively. So when an atom or molecule gains or loses an electron, it becomes an ion. So a cation is positive charge and anion is a negative charge, as a summary. And this anion and cations, we could list it at the periodic table, as shown here. So the alkali metals and alkaline earth metals are both of them, they make cations because they lose their electrons easily. But what we see here, halogens and nonmetals elements, they don't lose their electrons. Contrary, they accept electrons and they form the anion when they are supposed to do or need activity. So this side of the periodic table are anion, and this side, I mean the left side of periodic tables are cations. They form cations. So we couldn't see sodium Na minus. It's wrong. We said always Na plus, and you couldn't see O, the oxygen, O plus. It's wrong. We always see O minus 2. Okay? We could list it here in the periodic tables. So the elements with 1 or 2 or 3 electrons in their outer shell tending to lose electrons to fill their outer shell and become cations. So these are the metals which always tend to lose electrons. They are the property of metals that they tend or they lose their electrons easily. But when we have elements with 5 or 7 electrons in their outer shell, they tend to not to lose but to gain electrons to fill their outer shell and became anions. So that we don't have alkaline and alkaline earth metals. They lose and they couldn't gain electrons because they have a few one on their outer shell. So the non-metal would always tend to gain electrons. And the semiconductors, like metal weight, occur at the dividing line between metals and non-metals. They could be metals sometimes and could be non-metals sometimes. It depends on the elements. Okay, so as a summary, at the end, we could see here the example of sodium ion. So sodium is in the group 1A, it's a metal, and so he would lose an electron. You can tell how many would be lost by the group number, only one electron. So we could write Na plus 1, Na plus 1. So remember always that an electron is negatively charged. So when you lose them, atom becomes positively charged, and when you gain them, it becomes negatively charged. Okay, this is, I know this knowledge, all of both of you all, is known for you. I mean, it's not news, and just the aim of this lesson just to hear them in English and to know, appreciate the words, how to tell it in English or write it in English. Okay.
Okay.
If you do have, thank you. If you do have questions, thank you very much for your assistance with me. It's
Thank
really
you.
kind of you. And if you don't have any questions, I'm going to wish you a good weekend and tell you bye-bye.
Goodbye. Good weekend.
Thank you for your
Thank you, Miss.
assistance. Thank you very much.
Thank
And
you.
have a good weekend. Hearing you next Wednesday.
Okay,
Inshallah.
inshallah.
Okay. Thank you very much. Thank you for assistance with
Welcome.
me
Goodbye.
this evening. Thank you very much.